This chapter covers the following topics: PLC programming concepts and numbers, codes, and data types. Completion of this chapter will help you learn important PLC terms and develop an understanding of basic PLC concepts. Siemens Totally Integrated Automation Portal, TIA Portal, software is used in all phases of automation system design, operation, and maintenance. TIA Portal combines the software editors needed for these various tasks into one engineering tool. The user can choose between the portal view, which guides the user through each engineering step, or the project view, which offers fast access to all relevant tools. The portal view is a good place to start for a new user or anyone who wants to proceed with the development of a project in a logical sequence. In Portal View, the available tasks are clearly identified, such as create new project, configure a device, or write PLC program. Selecting Configure a device allows the user to quickly and easily set up a new device. Device types are easily located in a searchable hardware catalog. Configuration and networking for the entire project are performed in the device and network views, which display graphical representations of devices and allow network connections to be created using a simple drag-and-drop approach. Configuration is further simplified by using TIA Portal to detect connected devices. For example, the accompanying graphic shows a TIA Portal project view after an S7-1200 PLC has been detected. In this graphic, a picture of the S7-1200 PLC is superimposed on the TIA Portal screen to show how realistic the device image is. Preparing a PLC for use in an automation system requires configuration of devices and networks and programming of the PLC and related devices. For Siemens PLCs, the following engineering software is used to perform these functions. S7-300 and S7-400 PLCs require Step 7 Professional TIA Portal or a version of Step 7 Professional which is not in TIA Portal. S7-1200 PLCs require Step 7 Basic TIA Portal or Step 7 Professional TIA Portal. S7-1500 PLCs require Step 7 Professional TIA Portal. Step 7 engineering software runs on a personal computer, PC, that has a Microsoft Windows operating system. Siemens sells a variety of industrial PCs that can be used as programming devices. For added convenience, the SIMATIC Field PG comes with pre-installed SIMATIC TIA Portal engineering software and is optimized for mobile configuration, commissioning, servicing, and maintenance of an automation system. Step 7 Basic TIA Portal is used for the configuration and programming of S7-1200 PLCs and related devices. This can also be done using Step 7 Professional TIA Portal. However, Step 7 Basic is a more economical approach when other PLC models are not being used. Step 7 Basic supports the following IEC 61131 programming languages. Ladder diagram LAD, shown in the accompanying graphic, is a graphical programming language originally derived from the diagrams used in electromechanical control circuits, but which has been expanded to include much more advanced capabilities. Function block diagram FBD is a graphical programming language similar in capabilities to ladder diagram programming. Structured text is a high-level programming language that is also known as Structured Control Language SCL. SCL is particularly suitable for the programming of complex algorithms and arithmetic functions. Step 7 Basic allows program elements to be dragged and dropped into the program and the logical arrangement of these elements to be modified in the same way. As shown in the accompanying graphic, a user program for an S7-1200 PLC can include a full range of instructions such as Boolean logic, counting, timing, comparisons, math, and much more. In addition, commonly used instructions can be easily saved as favorites for convenience. As previously mentioned, Step 7 Professional TIA Portal is used for the configuration and programming of S7300, S7400, S71200, and S71500 PLCs and related devices. In addition to the LAD, FBD, and SCL programming languages included in Step 7 Basic, Step 7 Professional also includes the following IEC 61131 programming languages. Statement List (STL) is a low-level text-based programming language. Statement List is also known as Instruction List (IL). Sequential Function Chart (SFC) is a graphical programming language included in Step 7 Professional as S7 Graph. In S7 Graph, steps are shown in a sequence, making it easy to see the order in which events will occur. Step 7 Professional also includes S7 PLC Sim software, which simulates a controller for functional testing of user blocks and programs on the programming device. A PLC executes its program in a cyclic manner referred to as a scan. A PLC program can be organized as a linear program or a modular program. As shown on the left in the accompanying graphic, a linear program has all the instructions in one block and executes these instructions in sequence in each PLC scan. A linear program works well when the program is simple and does not need to vary from one PLC scan to another. As shown on the right in the accompanying graphic, a modular program is composed of multiple program blocks. Some program blocks are executed in each PLC scan, and other program blocks are executed under special circumstances, such as during startup, at specific times, when a special process event occurs, or when an error or interrupt occurs. An interrupt is a special signal or condition that causes a PLC to immediately perform a specific task. In programming terminology, when a program block initiates another program block, the initiating program block is said to call the other block. This causes the calling program block to temporarily halt its execution until the called program block completes its execution. Then the calling block resumes its execution. As shown in the accompanying figure, program blocks can also be nested. This means that one program block can call another program block, which can call another program block. This provides additional flexibility in programming. As compared to a linear program, a modular program with program blocks that perform functional tasks is easier to understand, develop, and debug. In addition, a modular program often performs better because it can vary the tasks from one PLC scan to another based on the needs of the application. An S7 PLC program can include data blocks, DBs, and three types of program blocks: organization blocks, OBs, function blocks, FBs, and functions, FCs. Program blocks, also called code blocks, are blocks that include instructions. The term function block does not mean the same thing as function block diagram, FBD. FBD is a programming language, and any of the three types of program blocks can be programmed in any of the allowed programming languages. OBs define the structure of the program. Every program must have at least one OB. If it has only one OB, that block is defined as OB cycle OB1. In a linear program, all the code is in OB cycle OB1. A modular program can be composed of multiple OBs, each with a unique name and number. OB cycles, such as OB1 and OB124, are the main program blocks, and they control the execution of the user program. OB cycle OB1 is called a program cycle OB because it is executed each scan while the CPU is in the run mode. A PLC program can have additional program cycle OBs as well as other types of OBs that are executed conditionally, such as at startup, at set time intervals, or when an interrupt occurs. FCs and FBs contain the program code that performs specific tasks. An FB uses an associated DB. An instance DB stores data for one FB. A global DB contains data that is available to any code block. An FC cannot have an instance DB, and the output data values from the FC must be written to memory addresses or to a global DB. FCs and FBs are often referred to as subroutines. A subroutine is a portion of a program that is executed when certain conditions are met. A common modular program application involves one PLC controlling multiple machines or devices with the same functionality. For example, a factory may have multiple motors that must be controlled in the same way by the same PLC. As shown in the accompanying graphic, this can easily be done using one FB that is called multiple times per PLC scan using a different instance DB for each motor. S7 CPUs have the following memory areas: load memory, work memory, retentive memory, local memory, and global memory. The amount of each memory type available varies with the CPU model. Load memory stores all code blocks, data blocks, technology objects, and hardware configuration. Load memory is retentive memory, which means that its contents are retained in the event of a power loss. Load memory for an S7 1500 CPU is stored on a SIMATIC memory card. Load memory for an S7 1200 CPU can be stored either in the CPU or on a SIMATIC memory card. A SIMATIC memory card can also be used to transfer the user program and data to another CPU. The CPU copies some elements of the user program from load memory into work memory during program execution. Work memory is volatile memory, which means that the contents of work memory are lost when power is lost, but the CPU restores work memory contents when power is reapplied. Work memory in an S7 1500 CPU is divided into two areas: code work memory and data work memory. Code work memory contains parts of the program code. Data work memory contains parts of the data blocks and technology objects. Retentive memory is non-volatile memory for saving a limited quantity of data. For example, the tags and operand areas that have been defined as retentive are saved in retentive memory. Local memory L is temporary memory used during the processing of a program block. Global memory is memory that is accessible to any program block in the user program. Global memory includes bit memory M and image tables for inputs I and outputs Q. Most instructions in a PLC program interact with one or more bits, bytes, or words in the CPU memory. The amount of memory used depends on the type of instruction. The specific memory locations used are identified by operands. For example, the instructions shown in the accompanying graphic each use a 1-bit memory location. The operand for the normally open contact instruction indicates that this instruction is controlled by the I2.4 status bit, and the operand for the output coil instruction indicates that this instruction controls the Q3.2 status bit. This type of operand is called an absolute operand and is preceded by the % symbol when displayed in Step 7 TIA portal. Step 7 also allows use of alphanumeric tags as operands. Tags are useful because they aid understanding of the program. A tag preceded by # is assigned to one program block. A tag enclosed in quotation marks is available to any program block. For example, a normally open contact instruction might have a tag such as jog motor 2 to indicate that it is being controlled by the jog push button for motor 2. Or an output coil instruction might have a tag such as motor 2 to indicate that it is controlling motor 2. As shown in the accompanying figure, one way a tag can be created is by assigning it to an instruction in the user program and then dragging the tag to the associated input or output in the device view. As tags are created in the user program, they are also added to the PLC tag table. Another way to create a tag is by entering it into the PLC tag table directly and then dragging the tag to an input or output in the device view. With either approach, the PLC tag table is a useful tool for keeping track of tags.